Welcome to Physics Problems 1 by 1.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is this puzzle and I try to solve it, and I right away tell you what was wrong with the previous solution. The assumption that as soon as f becomes bigger than mu mg, this body starts to slide on the surface of the second body is wrong. It's very natural. It's very natural to make this mistake, because we know that if the body sits on the surface and we apply F, then of course immediately as soon as F reaches mu mg, I draw this graphic many times, boom! F friction becomes maximum and it is mu mg or mu n, and then it becomes kinetic friction. But it's wrong here because this body can move too. So this assumption that as soon as F becomes greater than mu mg, it becomes kinetic, this assumption is wrong. If I wanted to make like a video with a lot of computer tools and animation, I would put here a red cross and everything, but I am an old man, I don't want to do it. I use chalk, I use board, I try to use my brain as much as I can, but all I say is that this is wrong. Because actually, I don't want now repeat this part with the sum of all functions, sum of all forces equal ma, proportion x, projection x and projection I. I already think that you're comfortable. I can tell right away that along the top body we push here F minus F friction, and I say that let this be a kinetic friction. Then it would be mu n equal ma1. And I can say that this is F minus mu mg equal ma1. And I say that this is really the case when a1 we can find from here, we can say that it is F minus mu mg divided over m. And this is acceleration of this body. But regardless of this, I can say that my second body moves, and what pushes it is friction, and friction is mu mg. Mu mg, let's write it slowly. F friction equals m, and I put a2. And instead of F friction, yes, it is the same friction, which is mu n, which is mu mg, so mu m lowercase g equal m uppercase a2, and I immediately receive a2 equal mu mg. And I divide into m, and this is a1 and a2. And important condition is that I will remove all of this. I remove all of this. And to save space, I put a2 on top, preparing the room for myself. a2 equal mu mg divided over m, so I can wipe it out. And so this is a1 and a2. And for me, in order to say that this body slides over this body, I have to say that a2 is less than a1. And I can say that mu mg divided over m is less than F minus mu mg divided over m. And let's check this little kind of situation when they are equal. So they are not the same, they are not a1 greater, but this is just a moment when we apply such force that this is, on one hand, this body is still moving with the same acceleration as the bottom one, but on the same, so it's not inequality but equality, but at the same moment I still can say that friction is m mu mg is the maximum friction available. So I use kind of conditions from both worlds. From kinetic I use this equation, and from static I use this. So those are the same. And let's find f from here, for example. Let's multiply this by m and multiply this by m, so this will be gone, or we can also simply say this goes here and this becomes mu m squared g equal f m, this is m capital, minus mu mgm, and this is fm, stays there, but I bring it, so I will do it slowly. Mu m squared g plus mu m lowercase m uppercase g equal fm. Now I move up because I don't have room here on this small board, right? And I say fm, I write it first, and here I factor what is common, mu mg, and from this I have m, and from this I have m capital, right? And then I divide into m, both cases, and I have f equal mu mg, and here I have m plus m over m, and let me write it one other piece of transformation. So f equal mu mg, and here I write 1 plus m over m capital. And so this is a force that triggers, kinetic friction, that triggers the slide of the top body over the lower body. And if you plug the numbers, you will see that the force that's applied is less. Because let's find this maximum force, it would be 0.3, m is 10, g is 10, and it would be 1 plus 10 over 20, it would be 1/2, it would be f equal 30, multiply 1.5, f equal 45 newtons, and we have only 35 newtons. So, quite a bit of difference. We assumed that, and it was very wrong assumption, that we will start slide, and because we're sliding we have kinetic friction, is this force applied to this body is bigger than mu mg. And that was wrong. 3.5 is indeed, 35 is indeed greater than 30. But the truth is that it needs to be greater than 45, and it's not. And that's a trap, if you wish. But now let's talk about why this is the case. Why we need more force. And that is because when I'm applying this force through the friction, it transferred, as we see through this friction, this is third law of motion, to the lower body. And so when we're applying this force, not only we're accelerating this body, we're accelerating the bottom body as well. So if we apply this force to the sum, and let's say we, in the case of static, we have m plus m multiplied by a. So we're not applying this force fully to this, we're applying only 10 and 20, 1/3 of this force is applied to this body. Another, they all move together, and 2/3 of this body is used, if you want to say it, to provide acceleration of the bottom body, and they kind of glue together because of static friction. And 2/3 of 35 is roughly 22, 23. So it's only 12 Newton are pushing this body actually, and 12 Newton is not enough to overcome the maximum force here, which is quite different as we saw. So that's the trick, that's the explanation, and that's explanation of this physical meaning. So once again, you have to check that acceleration of upper body is greater than acceleration of the lower body. You have first to find both acceleration and then check it, and only then you will receive that maximum force that causes the slide of the top body over the lower body should be much more, because not all this force is applied to this body, but through third law of motion it also accelerates the body. It's taking away. So, I hope you liked it. Subscribe, bell, like, comment, questions. See you next time.